Great. Hi everyone. My name is Olivia Adair, and I'm a just recently finished my PhD, and I'm talking today about a shiny new way to evaluate bowel cancer screening program in Northern Ireland. So for my PhD project, I created a cost effectiveness model for the Northern Ireland bowel cancer screening program. And in this talk today, I'm going to talk about the R-Shiny dashboard that we created to communicate our results to the screening program. So to start with, I just wanted to give a quick background of colorectal cancer. So it's the fourth most diagnosed cancer in Northern Ireland. And there is a screening program in Northern Ireland, and it was initiated in 2010. It screens individuals ages 60 to 74 every 2 years, and it uses what's called a fecal immunochemical test or FIT test. And it has a positivity threshold of 120 micrograms of hemoglobin per gram of stool. So if there is that level of hemoglobin in your stool, you're offered further investigation through the endoscopy services in Northern Ireland. So in 2018, the UK National Screening Programme Screening Committee recommended that individuals should be screened for bowel cancer between the ages of 50 and 74. So the screening program are very keen to reduce the age down to 50, and also look at different screening strategies to improve their program. So that's what my PhD project was on. We looked at different screening strategies. So we looked at different starting ages. So again, we have our 50, but we also looked at 52, 54, all the way to 60. We also looked at different FIT thresholds. So currently the screening program is 120. So we looked at 100, 80, 40, and 20. And we looked at different combinations of that. And for the PhD project, we wanted to find the most optimal screening strategy. And I built a microsimulation model in R, and built it so that it would be designed for the Northern Ireland population. And in this project, and what I'm going to talk to you about today, we were able to communicate these findings using an R-Shiny dashboard, which was great. Okay, so just a bit of background in how we built the model. So like I said, we built it in R. We use individual level microsimulation model. We incorporated elements of discrete event simulation, like time to event modeling, rather than modeling in a cyclical nature. We also calibrated our input parameters using Bayesian computation, calibration even, and use Northern Irish data to be able to align the input parameters. And like we were talking about, like was discussed on Friday, our model was pretty big. So we were able to use Queen's as a high performance computing system, Kelvin 2, to be able to run these simulations. When we were running our PSA, when I had it programmed on my own laptop, it was going to take about 6 days, but thankfully through Kelvin 2, we were able to parallelize the code and run it for 6 hours, which was a huge help. For the output that the screening program were very interested in knowing, they wanted to know a lot about capacity and whether they could looking at these different screening strategies was feasible to their capacity constraints. I don't know if any of you know, in Northern Ireland, the waiting lists, about 500,000 individuals in Northern Ireland on a waiting list, and this screening program are quite stretched as it is in terms of capacity. So they wanted to know about how many people would be invited into the screening program, how many endoscopy services they would have needed. They also wanted to know about some of the economic outputs, like our costs, our qualities, our ISRs. And then they also wanted to know about different analysis performed. So we have our scenario analysis, we have our one-way sensitivity and probabilistic sensitivity analysis. So as I was saying, this model is huge, and being able to communicate these results and the outputs of these results to a wide range of stakeholders was quite difficult. So we had stakeholders who were involved in the screening program, clinicians, academics, pathologists, patient representatives. So we really wanted to communicate these results in a way that allowed these stakeholders to make actionable decisions and to be able to present these results to the likes of the Department of Health to make changes. So we decided on building a dashboard which had the model results. So we were able to run the model using Calvin 2, and then we were able to present the results rather than the screening program looking at a mountain of code or having to wait 6 hours for a PSA to run. So it was great about this dashboard that was very transparent. We were able to communicate the results, and they had an opportunity to interact with the model. So I think I'm just gonna quickly show you a demonstration of the app. So let's hope this works. Can you see that? Yeah. Yeah, great. Okay, so there's 5 different tabs. I don't want to go into a whole load of detail on every tab. I just wanted to give you a flavor of what we had for the screening program. So the first 3 tabs are more information. So our first tab introduces the rationale of this project and the different features that are involved in the project. We also have our natural history model component and our screening model component. So this model is actually has been submitted into pharmacoeconomics. So hopefully in the next few weeks or few months, the model structure and the paper associated with this model will be published, and you'll be able to look in more detail. But for the screening program, we wanted to just quickly show what this model was actually doing. So this is our natural history of our model and how we simulated colorectal cancer progression through the Northern Irish population. I also included at the bottom where we got our input parameters or even the data sets, but again, not going into too much detail to overwhelm the screening program. And then we also had our screening model that was validated with the Northern Ireland Bowel Cancer Screening Program team. And we went through rigorous stakeholder meetings to make sure that we were modeling what actually happens in the screening program. So yes, we have our control logic model diagram. We have all of our costs associated. We have our utilities. And we have our screening program data, and then we also included our diagnostic test characteristics. So this is the different levels of fit for the positivity thresholds, and this is our sensitivity values for our different sizes of what's called an adenoma, which is the abnormal growth in your colon or your rectum that eventually could potentially become cancer. And we have it for different sizes of adenoma, and then we have our cancer. So that's just a bit of background about what the model does. But this is what the overall model result is, where the program can really interact with the model. So we first have our cost effectiveness plane, and if you hover over these different shapes and colors, we have our different strategies. So we have different colors indicate starting ages, as we have over here, and then the different shapes are our different fit. As you can see, as I move up and down, you can see age 60, fit 40, and then we have our comparator down here, which is age 60 and fit 120. So the screen program can look at that. We also have presented our one-way sensitivity analysis, again, just to show quickly show to the screening program what parameters influence the ICER the most. And again, they can hover over these different bars to see the different values. We also have a combined results table. Now, this is more for the screening program because they were very interested in the the capacity that would be required for each of the different strategies. So we have our starting age and our fit on this side, and then this is if we scroll over, we can see the capacity of how many are invited all the way to how many will have a colonoscopy performed or CTC, and then how many will lead on to being diagnosed with cancer and then cancer averted and death. So this table is quite difficult to compare one strategy against the other. So I have another tab that you could look at one strategy, which is this is our current program. And then this is another one, and this is actually our most cost-effective one. So if you compare these different strategies, you can have a smaller version of that results table that I showed in the previous tab. Then I looked at the incremental difference, which is just this table, only showing you where the increases are in the table and then where the decreases are. And then we also have our cost effectiveness comparison table down here. I also included a tab for individual strategies. So say you wanted to look at our current strategy. You can look at what the capacity looks like for the different ages, not the different ages, different years. So we screened, we simulated the model for 40 years. So there's 40 years of data there. I know I'm going through this really quick. The PSA plot is also presented. So this is the original value that was in the cost effectiveness plane. And then this is our different, this is the different values after running the PSA. We also included a couple of tabs for capacity. So this is how many, this is actually, you can't really see the effect of this. If I hit starting age at 50 and keep it at fit 120, we can have a results table, we have our PSA, but we also have our colorectal cancers detected. So this red line is what happens when the current strategy is employed, and then we also have what happens when we employ the new strategy of age 50, fit 120. So as you can see, a sharp increase at the start, and then it eventually follows the same kind of trend as the normal current strategy. And then this is looking at the number of averted deaths, cancers over time. And then this is the number of deaths averted over time. And then we also looked at how many colonoscopies and CTCs would be needed each year. So as you can see, sharp increase at the start, and then it kind of plateaus out as parallel to this other the current screening strategy, and same for CTC. So I just wanted, that's really the dashboard. So I just want to finish up here. So one of the lessons we learned from this project was that the model and explaining the model with no visual aid was quite difficult. So it was great that we had feedback from this screening strategy, from the screening program, to show that a dashboard was really helpful for them. When we started developing this dashboard, we had the screening program with us at the start, so they helped with the pilot dashboard that we built, and told us what to improve on and what was more helpful for them. They gave us some feedback saying that when they were able to use this dashboard, they were able to understand the results a little better. This dashboard is going to be housed in the PHA, which is our public health agency here in Northern Ireland, so it's not available for public use. But it's just whenever we get model results out, we can in our paper we can disseminate these results a wee bit better. So just to conclude, our model that we built for the screening program was quite computationally heavy, and it was difficult to understand when you're looking at all the code. So this was a great way to combine our advanced modeling methods and put it into an intuitive tool to be able to demonstrate the results to the screening program. The screening program are actually going to be using the results of this model to feed into a business case for the Department of Health to be able to make these changes to the screening program, which is very exciting. In terms of this dashboard, there are a lot of things we can do and change. So we can, whenever new data comes from Northern Ireland, we can update the model and then update the dashboard, and we can also incorporate different screening strategies as the screening program want. So Yeah, so it's been a great project. I know I didn't talk a lot about the R code and everything, but I was just showing you an example of what our dashboard did. So thanks so much for listening, and I can take any questions now.
Fantastic, Olivia, and very well kept to time as well. So there's a quick plug from Rose for a course in making Shiny apps and a question from Howard. Where did your test accuracy estimates come from? And are the sensitivity and specificity probabilistic? It wasn't clear if you let users change the point estimates, but it would be interesting to let them input their own sensitivity and specificity for new diagnostic tests or subgroups.
Okay, so our test accuracy estimate is that I'm guessing of the for the fit threshold. So we conducted a systematic review, and we didn't have any data for the test characteristics for Northern Ireland per se. So we were able to use estimates from the UK, from the systematic review that we did to look at different modelling methods and assumptions for screening program models. In terms of point estimates, so this dashboard wasn't the actual model. This was the model results. So the you couldn't alter without sending it away to our HPC system. You couldn't actually run the model per se, but the point estimates that were included were uh, we went through from our stakeholder engagement. We were able to say ask the stakeholders if they or the screen program if they're happy with these input results. So yeah.
I think that answers part of Dawn's question about how the model
Okay.
interacts with the HPC. So you didn't, so you ran the model on the HPC and then stored results with Shani, and Shani was picking the results as opposed to going back
Yeah,
to the server and
exactly.
rerunning everything. And the second part to the question from Dawn, the model looks great, which is true. Will it be available for other researchers to use and adapt?
And we are the dashboard itself. I'm not sure because we are housing that in the public health agency, but we would like to make this model code. We are wanting to make this model code, if even pseudocode, available soon. But just following on from what Raymond said on Friday, it would be great to make it open source, and also help other modelers to learn from what we did and then critique it as well.
And there's some congratulations from May on doing a really difficult topic in your PhD, which is screening program modeling. And one aspect of that that's difficult is checking model calibration to see if we're actually recapitulating natural history and population level disease incidence. Is that something you've done? Or I guess you didn't present it because it's not really part of the results, but how did you calibrate it?
Yeah, so we actually will that will be one of the elements in the paper that we've submitted to pharmacoeconomics. So hopefully that will be released soon. But we used approximate Bayesian calibrated computation. So instead of using Bayesian calibration, using maximum likelihood functions for fitting the model input parameters to observed Northern Irish data, we use goodness of fit estimates, and it was helpful, especially when our microsimulation model was so complex and computationally heavy as well. So we were able to, that will be covered in that paper. So hopefully we'll have it out soon. But yes, you're right. We didn't include that in the dashboard because
Sure.
that was something that happened before the model was even running its output.
And just as a final quick question, it sounds like this is something that's really going to directly influence policy. Where is the policy discussion on changing the screening program or otherwise?
So we're also thinking of writing another paper on that. Currently at the minute we're working with the screening program to develop a business case and present this to the Department of Health in Northern Ireland. We're actually altering the model slightly. So as I showed in the dashboard, that was us running the model. If we change the model tomorrow to age 50 and fit 100 or 20 or whatever. So we're looking at a phased approach. So what would happen if we reduce the age down over a 5-year period, a 4-year period, etc. So that's we're adapting the model to be able to reflect those changes and also look at how capacity changes, because that's one of the things that the screening program are most concerned about, is being able to, yes, have the most cost effective option, but also can they actually accommodate those changes.